Today's experiment is to study hair bridge. By using hair bridge, we can find the value of unknown inductance. So we have an unknown inductance here. So before doing this experiment, we have to find the true value of this inductance. We can find it by using a multimeter. So its values is 140.6. okay, 140, you can say 140.6. Now the value that we have measured from the multimeter is XL. XL is 140.6. okay. Now for finding the value of L, we have to use the formula XL is equal to omega L. Now we have to find this L. So L is equal to XL divided by omega. As you know that XL is 140.6, then omega is equal to 2 pi F. F is our frequency. We can put the value of frequency 50 Hertz. It's equal to 50. Now by calculating this, we got 3.447. Now this is a true value of L. The value of this unknown inductance. So now we will find this value by using this hair bridge trainer kit. So basically, while doing this experiment, we need a CRO to check the bridge's balance or not. So we'll start the experiment now. Now our connection is complete, so we can start the experiment. So for starting the experiment, we have to adjust the DSO for channel 1 and channel 2 to the 50 millivolt scale. For putting the DSO in the subsection mode, we can use this function mat, and you can see here the operation is in the minus position. So if it is not in the minus position, you can see there are many functions, a plus, into, multiply. So it is already the subsection mode. Now you can see from what we have to balance the bridge. Balancing the bridge, we have to change the value of this PT1, CT1 and PT3. So now we will just check it. Now you can see, I'll just explain. Now this is the channel 1 and this is the channel 2. Since the operational is in a subsection mode, this is the difference between this between the line is the difference between this yellow line and the green line. So for balancing the bridge, we have to make this central line to a straight line, or minimum likely to straight line. So we'll adjust this knob and make it to a straight line. So this is almost a straight line. Now we can say that the bridge is balanced. Now as we have done the experiment, now we will calculate the value of Lx. Lx is equal to R2, R3 and C1. R2 is from the kit, we know that it is PT2, and R3 is PT1 and C1 is CT1. Now by measuring the value of PT2, we get the value of R2. It is 2.2 kilo ohms, and similarly for R3 it is 210 ohm, and for C1 it is 1 microfarad. So by putting the value of R2, R3 and C1, we can find the value of Lx. 2.2 into K is 1000 and 210 into 1 into 10 to the power minus 6. Now after calculation, its value comes to 0.462 Henry. Now this is the calculated value, and our true value is this one, the value measured by the multimeter. So there is some difference in the value, so we'll find the percentage error. Percentage error 0.462 minus 0.447 divided by 0.447 to thousands. Its value comes to 3.35. The percentage error value is less than 10, so it is acceptable. So our experiment is correct.